Hi everyone, myself Amit Kumar Trivedi. I am here to teach you Chapter 1 Boolean Algebra of Class 12th Computer Science. Students, Boolean Algebra is a branch of algebra in which the values of the variables are the truth values, true and false, usually denoted with 1 and 0 respectively. Also define Boolean algebra as Boolean algebra is used to analyze and simplify the digital logic circuits. So now we'll start with the first topic of this Boolean algebra, that is propositions. As per the definition, the elementary or fundamental statement which may either true or false is known as propositions. We will see some example like it is raining. So it will be either true or false. No other value will be taken for proposition. Another example we will see, that is 13 is a prime number. We all know it is true. So I think these examples will make you clear that propositions will have either true or false, no other values. Now we'll move to next topic, that compound proposition. A compound proposition consists of two or more propositions joined by the connectives. We will see some examples. Example 1. It is raining and wind is blowing. Here we can see there are two propositions, it is raining, wind is blowing, which are connected with a connective and. We will see another example, take it or leave it. Here or is working as connective. In another example we see if you work hard then you will be rewarded. So here if then are working as connectives. Now about operator or connective. To combine simple propositions to form a compound proposition, we use operator or connective. We had already seen in previous examples like and, or, if then. These are the connectives. Now we'll see the different types of connectives available in Boolean algebra. These are disjunction, conjunction, conditional, biconditional and negation. Now we'll discuss them one by one. First we'll talk about disjunction or operator. It is represented by these symbols. Disjunction will be 1 or true if any of the propositions is true. Now in the following truth table we will see in last 3 rows combination at least one proposition having true value, whereas in first row combination both propositions having zeros. That's why in output column for first row it is 0 and for rest it is 1. This is conjunction and operator, which is represented by these symbols. Conjunction will be false 0 if any of the propositions is false. Now in this given table we can see the first 3 rows where at least one proposition, either A or B, having 0 as truth value. That's why in output column we are getting 0, whereas in last row both propositions having true values. That's why output is also true. Next connective is conditional, also known as implication, which is represented by these symbols. In P implies that Q. P is called antecedent and Q is called consequent. a conditional P implies that Q will be false 0 when P is true and Q is false. Now when we observe this table, we can see in the third row combination P is 1 and Q is 0. That's why the output will be 0 or false. For rest combination we simply write 1. Connectivist biconditional or equivalence, which is represented by these symbols. A biconditional P if and only if Q results into true if both propositions having same truth values. In this table we can see the first row and the last row, where both propositions P and Q are having same truth values. In first row both are false, in last row both are true. That's why in output column we are getting 1. For rest combination we are getting 0 because of they are having different truth values. Connectivist negation, not operator. Students, technically it is not a connective. Reason? Because it is a unary operator that takes only one proposition at a time and gives only opposite truth value of that proposition. In truth table you can see if A is 0, it is giving you 1. If A is 1, it is giving you 0. So these are the 5 connectives available in Boolean algebra. Now we'll talk about some terms which we will see in Boolean algebra. Start with first WFF, well-formed formula. As per the definition, the symbolic representation of a compound proposition that obeys the syntactic rules of propositional logic is called a well-formed formula. Students, in general WFF is also proposition, but a symbolic representation of that proposition. In simple proposition we can say it is raining, but when we symbolize it with a particular alphabet, that will be well-formed formula. So in other term we can also say कि a well-formed formula is a valid combination of proposition with connective or operators. Term now we will see contingencies. When propositions have combination of ones and zeros in the output column of a truth table. Now in given truth table you can see in output column we are having both 0 and 1. That's why it is known as contingencies. Next, tautology. When propositions having nothing but only ones in output column of a truth table, then it is tautology. Here we have taken one proposition A and its negation not A. Now when we use disjunction A plus not A, we will get only ones. So hence it is a tautology. The term contradiction. When propositions have nothing but only zeros in output column of a truth table. Here we can see A dot not A will give you only zeros. Hence it is an example of contradiction. Next, consistent statement. Two statements are consistent if and only if their conjunction is not a contradiction. Now in this truth table we can see A dot B is not giving you a contradiction, means for all possible combination we are not getting 0, at least for last combination we are getting 1. That's why it is a consistent statement. Students, here we conclude for today. On next turn we'll discuss about other terms of this topic, Boolean algebra. Thank you.